The free response questions on the AP Pre-Calc are all pretty consistent. So FRQ1 focuses on composition of functions, then it looks at the graphs of functions and evaluates them, looks for transformations and zeros, and analyzes the end behavior of them, and then it works with inverse functions as well. So if we look at this problem here, first we begin with an f function and a g function. F function is a table, g function is an equation. The first question is a composition of functions, so notice it's g of f of x. So if we look at the g of f of x, we work with the inside function first, the f function, which is designated by the table up here, and we want to evaluate h of 5 means that we plug in a 5 for this x. So the inside function, inner function, f of 5, the input of 5 gives us an output of 35. So I can replace f of 5 with its value 35. And now I can evaluate this g function for 35. So I have two options. One, I can type the whole g function into Desmos. So g of x is equal to, if I put that whole function up here, x cubed minus 25x minus 16, all divided by x plus 5. So here is our graph for this. So the easiest way to evaluate this is to now just evaluate g of 35. I get 1049.6. So I could just enter that number. Now the other option here is to do the calculation. So if I want to evaluate g of 35, I could have also just taken this function, and everywhere there's an x, I could replace it by 35. So I have 35 cubed minus 25 times 35 minus 16. I put that whole thing over 35 plus 5. Again, if I just enter 35 everywhere there's an x, I'll get my same solution as well, 1049.6. The next question is the inverse notation. So this is asking for the inverse, that's saying that we're taking the inverse for the f function of the input of 3. Remember, inverse, you exchange the input and output. So here we're looking at the inverse of 3 is going to be equivalent to the function that has an output of 3 in the f function up above. So the output of 3 occurs right here. So its corresponding input is also 3. It won't always be the case, but that is the answer for this. Next, the positive value for which the g function is equal to negative 1.6. So if we type that in as a straight line, so y equals negative 1.6, we can then look to see where these graphs intersect. Notice there's 3 instances where this happens. So here are our 3 intersections. So we have negative 4.656, I'll round to 3 decimal places. We have 5, and we have negative 0.344, and again negative, and again at 5. So those are our zeros. This asks for find the positive value, so the only answer that we are going to keep from these 3 is the 5. Next, if we look at the end behavior of this graph, the g function right here, as x approaches negative infinity, notice as you're looking at that, if you don't zoom out properly, you might think that it goes down. But if you zoom, you actually see as you move to the left, this graph is going higher and higher and higher. So the answer is going to be infinity for that. And then finally, this is saying use the table of values of f to determine which of these is the most realistic model. And so we can see up here that the numbers are getting bigger and bigger, but they're not growing by a constant amount. So if we were to look at the function for this, what you could see is if we took the successive differences, you could look. So here, I'm going to write those here. So from negative 13 to negative 7 is a difference of 6. From negative 7 to 3 is a difference of 10. From 3 to 17 is a difference of 14. And from 17 to 35 is a difference of 18. And so if we then look at the next, so we see that it's not a linear function because all of these numbers would be the same. If we look at the next set of successive differences, 6 to 10 is a difference of 4, 10 to 14 is a difference of 4, 14 to 18 a difference of 4. So if you have a constant change in the second set of successive differences, then you have a quadratic function. So that is going to be our answer here. And then finally, the reason, when you look, the second differences of change in output are the same. So that would be this option right here. And there would be my solutions.